Lesson 5, using matrices to organize data and solve problems. So, a matrix is just a rectangular array of numbers. So let's do an example. Here is a matrix. These two lines down are called columns. These three going across this way are called rows. If we want to name matrix A, we do the rows first, how many rows there are, by how many columns there are. So A is a 3 by 2 matrix. Hopefully you remember doing some of this last year. An element is just a number in the matrix. So 5 is an element in the matrix. Now if we drew A11, this means the number in the first row, first column. First row, first column is 0. A in the first row, second column, first row, second column is a 1. A sub 2, 1, that's second row, first column is a 2. A sub 2, 2 is a 3. A sub 3, 1 is 4. And A sub 3, 2 is 5. So whenever you see an element numbered like this, it tells you what row and what column you want to look at to be able to find that number. Whenever we want to add two matrices together, we call that matrix addition. You just add the elements that have the corresponding addresses. This is an address. So we just add the elements that have corresponding addresses. In other words, if you have two matrices, you would add the number in the first row, first column of the first matrix plus the number that's in the first row, first column of the second matrix. So when we talk about matrices, there's what's called commutative property. All matrices have commutative property for matrix addition, and that's the only thing. So it holds true for matrix addition. It does not for subtraction or multiplication at all. So commutative property is only true for matrix addition. The zero matrix is called the zero matrix if every element has a value of 0. So it's just a matrix with all zeros. The additive inverse of a matrix is where every element in the second matrix is the opposite of each element in the second matrix. So that if you add them together, so if you have A plus, and we call this negative A because each element will be the opposite, you're going to get the zero matrix. Every element will be 0. Those two matrices are additive inverses of each other. Subtraction, when we are subtracting two matrices, it's the same thing as an adding, only you just subtract. So you just subtract the elements that have the corresponding addresses. So we're going to do an example of solving a matrix equation. So here's our example. We want to solve. We have this 2 by 2 added to a matrix is going to equal this 2 by 2. So we're going to take, we're going to subtract this matrix from both sides. So x is going to equal this matrix minus that first matrix. And to subtract, we just subtract each of the corresponding elements. So 5 minus 3 is 2, 1 minus 2 is -1, 10 minus 6 is 4, 6 minus 5 is 1. So x is this 2 by 2 matrix. Then we have what's called scalar multiplication. That's just you're multiplying each element in a matrix by a constant. So for example, if I had 3 times this matrix, I would just multiply 3 times each of those numbers and I get 3, 9, 6, 12. And that's just called scalar multiplication. That's the end of lesson 5.